Hello and welcome to the sixth episode of Azure Database for MySQL Troubleshooting series. I'm Sai Kondapalli and I'm one of the product managers for Azure Database for MySQL. In the last few episodes, we have provided an overview into introduction for troubleshooting. We also spoke about the connectivity issues in MySQL environment and how to deal with them. We discussed about CPU utilization spikes and how to handle them in a MySQL environment. Similarly, we have also provided tips and tricks on how to deal with low memory issues in MySQL. Going further, we also provided how to optimize suboptimal queries in MySQL. And today we are going to discuss more on schema optimization and what are some side effects of schema optimization and how to get around them to make sure that your Azure database for MySQL database environment is performant enough for your workload needs. So today we are going to look at few topics. The first is how a bad schema design can affect your database environment as well as your application environment. Then we move into indexes and we'll look at what are some side effects of not having indexes as well as overusage of indexes that are not being utilized by queries. Then we'll look at some data type considerations and how you need to consider data types for your primary key design. And finally, we'll close today's topic with covering indexes. So there are a lot of effects that you can observe when your database objects are not optimally designed. Things such as integrity and inconsistency issues, such as when your schema is not designed properly, you may face issues such as referential integrity issues where you're not able to normalize your tables in a proper manner, and it can often lead to inconsistent retrieval of data sets. Scalability issues as well. If you were to add any further aspects of your application and if you were to make any schema changes on the database side, it can become cumbersome for you. A very simple thing such as adding another table that would refer the current database table, or maybe adding an index on a table can become quite cumbersome for you if you do not have the proper schema principles in place. And you can also observe underwhelming performance for your database tables, such as any over or under normalization of your tables can lead to significant performance problems where your query retrieval is very bad, as well as that can impact your DML statements, or if you were to do any sort of updates, etc., using DDLs, that can also be hampered quite a lot. And the maintainability part of it, such as adding or removing any objects from the table, such as adding indexes, removing indexes, can lead to extended browner periods because of the nature of bad schema design itself. So we'll look into some of the practices today and how to utilize them so that your schemas are optimally designed to overcome these side effects that you may otherwise observe. So first and foremost, before I dive into indexes, we all know that we leverage indexes for quicker retrieval of records in a table. They're more or less used as pointers where we can locate the record on the storage or in the buffer pool and immediately serve that for the incoming query from the application side. So what happens if there are lack of indexes on a table in the database? So the first thing that you would observe is your queries are performing very poorly. Instead of a query that is supposed to complete in certain milliseconds of time, you can see it taking a couple of seconds, few seconds, or maybe more, depending on how much data you're retrieving through that query. And on tables where there are no primary key indexes or clustered indexes, you can see that there are data storage issues with huge fragmentation that is happening in the background. And also the retrieval becomes quite cumbersome if there are no primary key or clustered indexes on the table. So how do you get around that? The recommendation is to basically tune your queries and your schema in such a way that you run execution plans by using explain in MySQL on these queries, which would provide you with set of recommendations as to where you need to add index, whether that be a clustered index or whether that be any secondary index, covering multiple columns for the query to be satisfied and be run in a very short period of time. And using that information, do add indexes that are lacking on your database tables for optimal query execution times. Let us move ahead and look at what having a very large number of indexes on a table and a significant number of them being unused can do to your databases environment, right? First and foremost, you have too many indexes on the table, it can lead to greater disk space utilization as well as cache consumption. And the second side effect of that part is that you would see a very significant slowdown for your DML operations. Any inserts, updates, deletes, they do get affected. Anything that's supposed to run in few milliseconds or few seconds would end up taking like quite some time. Could be a order of magnitude that you may not expect from your initial testing itself. So always do keep an eye out for indexes that are not being utilized by the queries on a table in your databases. So how do you get around that? Removing the unused indexes need to be done in a very strategic way. That is, you need to look at some of your information schema queries to understand which indexes are being utilized by which queries, and if there are any unused indexes, go ahead and remove them, so that you get around the disk storage issues, as well as the DML operations being slowed down to a point where all of your queries are being benefited for both the read statements as well as for any of the DML statements as well. Moving on, one of the other important topic of consideration is basically the data type and what sort of data type you would be picking for your fields in your table in the database, right? And why data type, having the right data type for a field is important. So first, let us look at some of the side effects that can be caused because of suboptimal data types that have been chosen for a field in a database, right? First and foremost, you may see higher storage utilization and decreased buffer pool efficiency in your database environment, and similarly increased CPU and IO utilization. A good example could be things such as dates, etc., are being stored in a format of char or varchar data type columns, which would mean that instead of this data type consuming 4 byte or 8 byte, it could end up consuming 16 byte or 20 byte. In those cases, you would see that the pages on the storage are quite long, as well as because the pages are long on the storage, you would observe that the CPU and IO utilization is always high when you're retrieving or writing to these fields that are suboptimal in nature. And what are some of the recommendations, right? So always try to think about your application way well in advance, so that you choose the right data type to address the business use case, rather than picking one of the data types such as integer for any representing any value, any numerical value, and instead picking varchar to represent any other value, right? So rather than that, look at the MySQL documentation to think about which data type would optimally represent your business use case, and at the same time represent the range of values for this particular field. And this data type design would also directly translate into primary key design as well, because when you're designing your primary keys, you need to be aware of picking the right data type for the primary key also, since every primary key in MySQL is a B-tree data structure and it leverages a clustered index. So let us look at what are some of the primary keys, right? So they are basically categorized into a couple of types. The first one is a natural primary key. And a natural primary key is anything that is already representative of a field or fields inside the table in your database. That could be things such as username, person ID, to uniquely identify a record. A single field or multiple fields to make it a composite natural primary key. Let us look at an example here. So in this particular employee table, we see that we are leveraging SSN to uniquely identify each of the record. Since we are leveraging SSN, which is a 9-digit value, you may see that it is a little bit of a longer representation on the storage itself, and the retrieval can also be quite cumbersome with leveraging such primary keys. This may be beneficial in cases when your business use cases determine that you do not want to leverage any extra fields to uniquely identify a record, but you would like to leverage the same fields that are already present in the database to identify and retrieve the records. And let us look at the other type of primary key that is available today, and that is surrogate synthetic, which is artificial in nature, or a system allocated or system provided primary key value to uniquely identify a record in a database table. And these can be auto incrementing in nature with integer values or any UUIDs to uniquely identify a particular record. A very simple example can be like an auto increment integer value to identify a particular record on this table. As you can see in this example, when you think about address, there is no other field that can uniquely identify a particular person's record, right? There can be multiple people living at a particular address. So to identify a person that is associated with that, it is good to provide address ID, which can uniquely identify that particular row in the table itself. So it becomes quite easier for you. And since auto incrementing integers are quite smaller in terms of storage, it provides efficient retrieval. And if you have multiple secondary non-clustered indexes on the table, when the non-clustered indexes have to point to the clustered index, it also becomes quite easier rather than pointing through a natural primary key itself. So let us look at some of the side effects that a natural primary key can impose in your database environment, right? So the storage is not efficient, as we have discussed earlier, leveraging things such as, a person's first name, last name as composite primary key, or an SSN that could be very long, and they're often wide, sometimes spanning across multiple pages as well. And since these are not ordered, there is no predetermined order in which they are stored on the disk itself, and this may basically cause page fragmentation issues. And when that happens, the retrieval times for some of the queries can be quite long, and it hampers the user experience for your application. And on top of that, if you add any secondary indexes that refer the natural primary keys, it can be very costly in nature for query execution. And those queries will also suffer, leading to a lot of timers that your users can experience when sending such queries from the application side. So how do you get around that? First and foremost, consider that every table should have a primary key so that the data retrieval is quite efficient. And since clustered index orders the table records on the storage, and always use the smallest data type that is possible to represent the range of values or the range of records that your application needs. And do ensure that the data type that you choose provides unique values and that uniquely identifies the record in a table. And it is a good practice to leverage auto incrementing surrogate or artificial keys when designing your primary keys. And finally, one other topic, hotbed for a lot of database users and practitioners, is covering index. So what happens if you have lack of covering index, right? So if you think about it, if you were to retrieve any record from the storage, there is a random IO read that happens if you do not have a covering index. Basically, your secondary index refers to the primary index, and then the primary key clustered index will then find the record. So this particular random IO read can sometimes be costly for queries in a very concurrent database environment. And sometimes you can also observe that, when these kind of select statements are happening, you can see that your update statements are getting a little bit blocked due to high concurrency issues, and you may also run into deadlock issues. So how to get around that? Create a covering index that can satisfy that query. And what we mean by covering index is that it covers all the fields that are going to satisfy a particular query statement. And they should be ordered from left to right so that each and every single field that is used in the select statement is present in the covering index. And if you do that, it helps you avoid any random IO reads. And all of the secondary indexes do not really have to refer the clustered index for identifying these rows. And it is very beneficial for IO-bound workloads in a highly concurrent database environment. So a covering index can provide you with lots of optimization and improves query response time. Hope today's tips have really helped you out in making sure that your schemas are properly optimized, and you would leverage this information for designing your schemas in an optimal manner. For more details about Azure Database for MySQL, tune into https://aka.ms MySQL resources. And for any recent product updates and announcements, please subscribe to our YouTube channel, follow us on Twitter as well as LinkedIn. Thank you for tuning into today's episode, and please stay tuned for more episodes coming in the troubleshooting series for Azure Database for MySQL.